All right, welcome to our next day of e-learning. Let's go ahead and jump right on into 6.10, finding the value of a relationship. All right, so we've got a couple parts here that we're dealing with today. Part 1, pick a side. Andrea and Benita are resting under their favorite tree before taking a nature walk up a hill. Both girls have been studying trigonometry in school, and now it seems like they see right triangles everywhere. For example, Andrea notices the length of the shadow of the tree they are sitting under and wonders if they can calculate the height of the tree just by measuring the length of its shadow. Benita thinks they need to also know the measure of an angle, so she checks an app on her phone and finds that the angle of elevation of the sun at the current location and time of day is 50 degrees. In the meantime, Andrea has paced off the length of the tree shadow and finds that it is 40 feet long. So our question here, and we've got a handy dandy little diagram down there, but our question here is how might Andrea and Bonita use this information along with their knowledge of trigonometric ratios to calculate the height of the tree? So we need to find this. So, Andrea and Benita know they can find the value of any trigonometric ratios they might need for an acute angle, any acute angle using a calculator, okay? So, we can actually use a calculator with that 50 degrees, put in a trigonometric function, and get a value out. So, let's do just that. What I'm going to do is I'm going to set up a trig ratio that includes both the unknown side, the known side, and the known angle. Okay, so if I'm thinking about my trig ratios, I've got sine, cosine, and tangent, which actually a helpful mnemonic to remember what ratios are involved with them is the mnemonic SOHCAHTOA. And it looks like this. And what that does is it helps to remind me that sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. So that's a helpful little mnemonic, SOHCAHTOA, to remember what trig function goes with what ratio. So because I have an opposite or an adjacent and an opposite side that I'm dealing with, I'm going to use tangent. So I will say tangent of 50 degrees is equal to the opposite, which is unknown, or excuse me, is equal to, the opposite, which is unknown, over the adjacent, which is known. Okay, just like that. So now I can do some algebra and multiply 40 to both sides. So I get 40 times tangent of 50 degrees is equal to x. Now, you'll notice on your calculators that you guys all have tangent buttons. So what you can do is you can enter in 50 into your calculator and then push your tangent button, and that will give you a value, usually a rounded decimal or something like that. So I'm going to go ahead and do that on my calculator right now. 50, push the tangent key. Make sure your calculator is in degrees right now, not in radians. That will change things. But tangent of 50 is actually equal to 1.19. Okay, so now I can multiply 1.19 times 40. And that gives me the value of 47.6 feet. So the height of the tree, or our unknown here, x, is 47.6 feet. Okay, so we were able to find that using a trig function, only knowing an angle and one side. Also, we know that this is a right angle. That's pretty important. Okay, so part 2. What is your angle? After the rest, Andrea and Benita are going for a walk straight up the side of a hill. But don't worry, it's not too steep of a hill there. But Andrea has decided to stretch before heading up the hill, while Benita thought this would be a good time to get a head start. Once Benita was 100 feet away from Andrea, she stopped to take a break and looked at her GPS device that told her that she had walked 100 feet and had already increased her elevation by 40 feet. With a bit of time to waste, Benita wrote down the trigonometric ratios for angle A and for angle B. So let's go ahead and do that as well. However, before we can do that, we need to know what the length of this third side is, right? So we're going to use Pythagorean's theorem real quick, where our hypotenuse is always c, so 100 squared equals 40 squared plus b squared. So we've got 10,000 equals 1,600 plus b squared, okay? And when I go ahead and I work this out, I get 10,000 minus 1,600. I get 8,400 equals b squared. And then what I get from there when I take the square root of both sides is that b has a length of 91.7 feet, okay? So this right here is 91.7. So go ahead and I'm actually going to ask you, well, in just a second, I'm going to ask you to pause and fill in all these values. But before we do that, I'll kind of write them all down with us. So sine A, cosine A, tangent A, and then sine B, cosine B, and tangent of B. All right, so go ahead and try to write down all those trig ratios. Pause the video. Well, let's go ahead and use our reference angle A first. So sine, which is so it's equal to the opposite over the hypotenuse. So sine is equal to 40 over 100, which reduces to 2/5. Cosine, ca, is the adjacent over the hypotenuse, so 91.7 over 100, which does not reduce well, so we're going to go ahead and just leave it. And then tangent, TOA, which is equal to the opposite over the adjacent sides, so 40 over 91.7. All right, we've got angle A trig ratios all taken care of, so let's try angle B's trig ratios. Okay, so sine, so equals the opposite over the hypotenuse, 91.7 over 100. Cosine, ca, the adjacent over the hypotenuse, 40 over 100, which reduces to 2/5. And finally, tangent, TOA, equals the opposite over the adjacent side. So there we go. We've got all our trig ratios for angles A and B. So now, when Andrea caught up, she said, what about the unknown angle measures, or the measures of angle A and B? When I was at the bottom, I looked up to see you, and I was thinking about the upward angle measure from me to you based on your picture. This would be angle A. So Benita wrote the trigonometric ratio, sine A is equal to 40 over 100, excuse me, and asked, so how do we find angle A then, right? We have it represented here, but how do we find it? Well, together the girls talked about how this was like thinking backwards. So instead of knowing an angle and using their calculators to find the trig ratio, like they did earlier, instead they now know the trig ratio and need to find the unknown angle value. Benita notices the sine to the -1 theta button, which we read actually as sine inverse of theta. And she noticed that and wonders if that might work like an inverse trig ratio button. Okay, so undoing the ratio to produce the angle is what she's looking for. So she decides to try it out and produces the following output on her calculator. And then she also decides to check her work as well, using that angle to see if it produces the proper trig ratio. So let's examine here. So we've got sine A equals 40 over 100. And what she does is she uses the inverse sine function to see if we can find an angle measure. Okay? She does that and finds the angle measure of 23.578 degrees. And then she says, okay, well, I want to check my work to make sure that my output, when I use it as an input of the original sine function, I want to make sure that I get my original trig ratio 40 over 100. So she plugs that in right there, and she finds that the output is 0.4, which is in fact just the decimal version of 40 over 100. All right, so looking at number 3, how might this output convince Benita that her assumptions about the calculator was correct? Well, we can look and say, okay, when I use this as my input, I get this output, and then when I use this as my output, I get this, or my input, excuse me, I get this output, right? Which is the definition of an inverse function, okay? You get the same output secondarily as was your original input, okay? So that's how we can be convinced that the calculator assumption was correct. So now we need to use the trigonometric ratio that we found for cosine B to find the value of angle B. So let's use cosine of angle B right here, this one, which is actually that same 40 over 100. So cosine of B is equal to 40 over 100. And I like to use inverse functions kind of like we would when we square things, when we square root them to undo them, or when we divide by something to cancel something off. I kind of do that same thing. So I'm going to go cosine inverse of this side and cosine inverse of this side. And guess what? Cosine and cosine inverse undo each other. So we're left with B on the left side. Okay, and on the right side, we're going to put that into our calculators. I know that this is 0.4. Okay, so I'm going to say 0.4 in my calculator. And then I'm going to push the cosine inverse button, and I get that B is equal to 66.4 degrees. All right, so that's how you use the cosine inverse. So when you have a ratio of side lengths, you can actually find angle measures as well. So let's go ahead, and for number 5, I want you guys to again pause the video, okay, and you are going to write all these trigonometric ratios, or write trigonometric ratios to help you solve for angles alpha and beta, and also use the Pythagorean theorem to find side C. So I'll fill these in for you real quick. 12, here we have 8, and you need to find C, alpha, and beta. So go ahead and pause and try it out. Well, hopefully you were successful. Let's go ahead and do this together. 8 squared plus 12 squared. I like finding my side lengths first. So I get 208 equals C squared. When I take the square root of 208, I get 14.4 meters, okay? Now we have some options, right? We have all the side lengths, and we could use any trig function that we'd like. Any of them will work to find alpha and beta. However, because they've given me exact values here and here, I am going to choose to use those values over the value that I calculated for. And a couple reasons for that. For one, I rounded that value. But I also, if in some situation ever I made a mistake or you made a mistake and this was wrong somehow, we don't want to use a wrong value that we solved for to try to solve for our angle measures here and here. So instead, we're going to give the values that they've given us. We're going to take those values and use them in our trig function. So thinking about our trig functions, which trig function has both the opposite and adjacent sides? Well, SOHCAHTOA. TOA is the answer, so we have opposite over adjacent, and that's tangent. So we will say tangent of alpha is equal to 12 over 8. Okay? And now to solve this, we're just going to do the inverse function, tangent inverse, and we'll do it to both sides, tangent inverse. Tangent and tangent inverse are inverses of one another, and they cancel. So we have alpha equals tangent inverse of 12 over 8. So I'm going to go ahead and put that in my calculator, 12 over 8. And I'm going to push the tangent inverse button. And I get 56.3 degrees. Wonderful. Again, I would also recommend that you continue doing these with me on your calculator so that you get comfortable using your calculator, using your trig functions and inverse trig functions, and making sure that your calculator is in degrees, not in radians. So let's do beta. So tangent of beta is equal to 8 over 12. TOA is opposite over adjacent. Okay, and then to undo that, I will use the inverse function, tangent inverse of both sides. Tangent and tangent inverse cancel each other off, and I get beta is equal to tangent inverse of 8 over 12. So 8 over 12, tangent inverse button, and I get 33.7 degrees. All right, so my alpha is 56.3 degrees. My beta is 33.7 degrees, and I found my third side length as well. So we are going to move on to number 6. Benita and Andrea started talking about the ways to find unknown values in right triangles and decided to make a list. What do you think should be on their list? Be specific and precise in your descriptions. For example, trig ratios is not specific enough. You may use the following sentence frame to assist you in writing each item on your list. So I'm going to give you one, and you can figure out the rest. So, for example, when given 2 side lengths, you can find the third by using the Pythagorean theorem. All right, so there's the first one. Now I want you to be specific, write maybe 3 more, and be specific about using things like sine or inverse sine to find angle measures, or sine to find those trig ratios. All right, so go ahead, pause the video here, write 3 more, and then you will meet up with me on the next page. Okay, so our last part here, part 3, angle of elevation and angle of depression. During their hike, Andrea mentioned that she looked up to see Benita. In mathematics, when you look straight ahead, we say your line of sight is a horizontal line. So let's say this is you. This right here, that's your line of sight. Okay? And what we say is that if we look up like this, that is considered an angle of elevation. Okay? So looking up from horizontal is the angle of elevation. And if we're looking down, this is the angle of depression. So think about elevation as upward and depression as downward from the horizon. Okay? So with that description, Andrea mentioned that her angle of elevation to see Bonita was about 23.5 degrees. They both agreed. Benita then said her angle of depression to Andrea was about 66.5 degrees. Andrea agreed that it was an angle of depression, but said Benita's angle of depression was actually also 23.5. But who do you think is correct? Use drawings and words to justify your conclusion. So let's real quick just draw Andrea here, Benita here. Okay, remember that we've got our horizon. Okay, and here's their line of sight. So what you need to do is pause the video and try to create an argument saying who you think is correct. Okay, so we know that this elevation right here is 23.5, the angle of elevation, degrees. Okay, and Bonita thinks that this angle is 66.5 degrees, and Andrea thinks that it's 23.5 degrees. Who do you think is correct? Well, let's look at this for a moment. We know that horizontal lines will never touch each other, right? Because they are completely horizontal. They will never cross, which means that they are parallel. Yeah. So if we have two parallel lines cut by the transversal AB here, we know something about their alternate interior angles. Okay? Alternate interior angles will always be congruent, okay, as we've seen in the past. So this angle of depression here, angle of depression, and this angle of elevation will always be congruent, okay, because they are alternate interior angles to that horizontal line. So we can answer with some confidence saying that Andrea's idea is correct, okay? So 8, what conclusion can you make about the angle of depression and the angle of elevation? Well, it is congruent. When we're talking about the same line, it's always congruent because they are alternate interior angles of parallel lines cut by a transversal. There you have it.